Good afternoon, everyone. My name is William Knowles from MWR Info Security, and today I'll be talking about different techniques for persisting with Microsoft Office. As is the case with most research around persistence, this talk will not be covering esoteric, highly technical ways of gaining arbitrary code execution. It'll be more about how you exploit the way that things are configured and legitimate extensibility options. Therefore, I hope it's not too much of a crushing disappointment to anyone that has sat down and is just realizing that you've effectively signed up for a 45-minute Microsoft Office training course. I have, however, tried to make it as interesting as possible by keeping it practical. There's a lot of techniques that I want to cover, and I've tried to include code snippets where relevant, practical guidance on configuring add-ins, etc., and lots of demos throughout. So to kick this off, why focus on Microsoft Office in the first place? And there's a couple of reasons. A big one is that Microsoft Office is so ingrained in the workflows of typical business users that if you were to compromise a random workstation, the likelihood that it would have Microsoft Office on is extremely high. Therefore, if you have persistence techniques for Microsoft Office, they're going to have a very wide application. And that, of course, is only speaking about persistence, but it has other uses too. For example, if you have a technique which requires you to drop a file in a folder, and then if you start an application, you get arbitrary code execution from the thing that you dropped in the folder, you can start using this for things like Citrix breakouts. Another reason was that I wanted to follow on a bit of research by a colleague of mine at MWR called Costas. This work was very much inspired by that, and that was around the topic of persisting through Office templates. And I wanted to very briefly cover this off to begin with, in part because it's very relevant to the talk, but also because it's a very nice way to providing some context and background on many of the other techniques which I'll talk about after this. So, very briefly, persisting through Office templates is based on the idea of trusted locations. That means they're trusted for VBA execution, so trusted for macro execution. What that means in practical terms is even if you disable macros elsewhere on a system, if you have a file with a macro in it and you drop it in one of these trusted locations, that macro is still going to get executed. Now, one of the things that Costas identified was that if you have a document on a system, and that doesn't have to be a macro-enabled document, it always maintains a reference back to its original template. And if that template file itself has macro code within it, when you open that document, that doesn't necessarily need to be in a trusted location. It will actually follow that reference back, and the code in the template file will get executed. So to very briefly show this, I put together this little demo. So here we have a docx file, so it's not macro-enabled. If we open it up, we don't get any code execution. We don't see any calc, which I'll be using throughout the talk as the proof of concept. If we go into the Trust Center for Microsoft Office and we look at the settings, we'll see that macros are disabled without notification. And if we look at the trusted locations, we see that there is this template location, and the location of that is in the user's roaming profile. So if they're using Active Directory roaming profiles, this will actually get synced with the user, but this could, for example, be on a network share. Now, if we were to close off this version of, skipped a bit. If we were open up the VBA editor for this particular document, even though it wasn't a macro-enabled document, it does maintain a reference back to the normal template. And in a default installation of Word, that's just a blank template file. So if we open up Microsoft Word again, and if we were to go to the location that the template files are stored, which was the app data roaming profile Microsoft templates, just open that up. You can see that there is that normal template file. It's a macro-enabled template. And if we open it up, skipped a little bit in the video there, but if we Alt F11 jump into the VBA editor for that particular document, add a bit of macro code which executes calc, and then save it off and close it. If we go back to that original document that isn't in a trusted location where macros are disabled, you get the code execution because it follows that reference back to its template file. Now, when looking at this, So there's obviously the use case of templates, and some of these trusted locations are very clearly marked as template locations. Some of the other ones, however, are not. They're marked up as startup locations, and that got me wondering, what is the difference between the two of them? What sort of files does Microsoft want us storing in these locations? Like, what is the fundamental difference? Because if you actually go to add a new trusted location, it doesn't say, do you want this trusted location to be a template location or a startup location? They're just sort of very generic. It's a very generic trusted location, but in a default installation, they are making that distinction between the two. So one of the things which I found that gets stored in these trusted locations is called a WLL file for Microsoft Word. And if you were to open up Microsoft Word and you were to look for references to the support of WLL files, you would find them quite difficult to come by. The only one that I personally found was about 4 or 5 submenus deep, even then, and only in an Explorer window in a drop-down box of supported file types. There isn't really much information on what WLLs are within Word itself, and indeed online there's not a lot of documentation about WLL add-ins. MSDN, however, of course, as always, has the answer, and that's that they're just a DLL which exports particular functions that allow you to extend what Microsoft Word is capable of doing. Now, what are these functions? What are their names? What are their arguments that they take? When doing this research, I had no idea, and to be honest with you, even now I have absolutely no idea what those functions are. But it turns out that the reason, perhaps, for the lack of documentation online about what these are could be that the WLL add-in itself was actually designed for Microsoft Office 1997 and hasn't received any updates since. But despite that, it is still supported in modern versions of Microsoft Word up to 2016. However, it's only for the 32-bit versions, which does tend to be the default installation version that you get anyway. So how do we use these for persistence? You know, if we don't know what functions need to be exported, it turns out that it doesn't really matter. You can literally just create a DLL and have sort of code in the DLL main function that gets executed when it gets loaded, and then rename that DLL to a WLL, drop it into the Word startup location, and then Microsoft Word will arbitrarily load it at runtime. So if you've never done any DLL programming before, this is what effectively it would look like. You have a DLL main function, and then a switch statement which says how you want to handle the DLL being loaded, whether it's attached or detached from a process or thread. In this example, just calling create process when it's attached to a process. Now, if you were to go away and try this, I would highly recommend you creating the DLLs yourself. I've personally found that if you're using frameworks like MSF Venom to generate DLLs, they do get loaded at runtime, but then they also lead to Microsoft Word getting crashing. It hangs for a while and then it ultimately crashes. Why, I'm not so sure, but I found that using a bare bones example such as this seems to solve the issue. One of the curious things about the way that Microsoft Word treats WLL add-ins is that even though it loads them and you get code execution, it doesn't treat them as an active add-in. I believe this is because I'm not exporting any functions. Maybe you have to export a specific function for it to be treated as an active add-in. But from an offensive perspective, it doesn't really matter. You're still getting code execution. But certainly, if you're in defense, it's something that you should be aware of. Microsoft Excel has a similar add-in called XLL, and given what we know about DLLs, it comes as no surprise that these are also, given what we know about WLLs, it comes as no surprise that these are also DLL-based add-ins. They are considerably more updated than the WLL situation. There was a software development kit released in 2007, so you are much more likely to come across them in legitimate use cases in environments. In this case, you do also need to export a particular function in order to get Excel to load the add-in, but the procedure is generally the same. You create an XLL file, you drop it into the startup location for Microsoft Excel, and if it contains this exported function, this function name is Excel auto open, that function specifically will get called. Microsoft Excel is quite interesting in the way that it treats files in the startup directory, because it's not really concerned with file types. It will actually fingerprint every file that you place in a directory, and if it understands what it is, and in this case if it exports the Excel auto open function, it will actually call it regardless of the file extension that the file has. So if you want your, if you generate your DLL, you don't actually need to rename it to an XLL. You can call it .txt or XYZ if you really want to. Again, a code sample for this, very simple, as is the previous case, you know, a very bare bones DLL. At the bottom there is this exported function, XL auto open, if you want to go away afterwards and generate that. You know, just use code like that, stick it in Visual Studio and get your DLL. So, show a very quick demo of this. We can see here that we've got a low privilege user, and not just his name, his group membership is nothing special. So if we were to open up Microsoft Excel, we could see that we get no code execution, or nothing executes, I should say, when opening Microsoft Excel. So if we go into the trusted locations again, so this time we're looking for the user startup location. So each user will have one of these startup locations, even as a, you know, so you don't require any special privileges to write to it. And once again, this is in the roaming profile, so it could get synchronized if they're using Active Directory roaming profiles. That between machines, that is, as someone sort of logs in on different machines in an environment. So if we hop into that directory, so the naming convention is slightly different here. It's XL start rather than startup. But on the desktop, we've got a text file, and if we look at that with dependency walker, we can see that that is really just a DLL file because it's exporting a function called XL auto open. So if we put a copy of that in the startup location for Microsoft Excel, open up Excel, we get code execution that way through text files in startup locations. This is, so the last DLL-based add-in that I'll talk about is Additional Actions DLL. This is a registry key property which I came across about a month ago. Effectively, all you need to do is create this registry key property at this location in green, and the value of the property points to a file on disk, and then Microsoft Word will load it at startup. It's quite straightforward. There's nothing special to it. It does, however, only work with Microsoft Word 2013 and 2016. It's interesting to know that the registry key location is actually not specific to Microsoft Word, but it only does work with Microsoft Word. Why the reason is for that, I'm not really too sure, but it is Word specific. In addition to DLL-based add-ins, you can also have add-ins that are written in VBA, and the way that you create one of these is very much the same as you would create a macro document. You open up Excel, you open up the VBA editor, you stick some code in it. The difference is when you come to save it, if you drop down the list of supported file types, you'll see that right down, hidden at the bottom of the list, there's some add-in specific types for Excel. And the file format of those is XLA and XLAM. And really all these are is Excel documents that don't have any spreadsheets associated with them. And that's quite interesting because originally I'd thought that, you know, there's a specific thing such as an Excel add-in, but it turns out because they're just documents that don't have spreadsheets, you can actually use any macro-enabled document. So if you want to use an XLS or an XLSM or even the binary version XLSB, you can do. And of course, because this is Microsoft Excel and it doesn't really care about file extensions, as long as the file format is correct, you can stick one of these documents in there and rename it to a text file if you want, and it will still get loaded by Excel at startup. And again, you just stick these in the startup location. It's quite straightforward. So even though you can change whichever extension, change the extension to whichever one you want it to be, you can't, however, use no extensions. That's something I should point out as well. Another sort of gift that Excel gives attackers is that there is a registry key property called open, which lives at this location, and you can have multiple of these keys. So you can have open and then an integer. And really, for this registry key property, what it allows you to do is, for example, in this case, you can use the /r switch, which means open a file read-only at startup, and then you can give the path of a file. It's really curious the way that Microsoft Excel treats this, because it treats it as if it's an additional trusted location. So you can stick a file on the desktop, disable macros, and disable trusted locations. and this document, when you open it, it's still going to get code execution with the VBA. So very briefly to show that, if we open up Excel again, nothing gets executed. If we go into the Trust Center again, we can see that in the macro settings, they've been disabled without notification. And in the trusted locations, all trusted locations have also been disabled. So really, we shouldn't be able to execute VBA code on this system. So in some situations, like if you have trusted locations enabled, you can specify whether or not you want to allow those trusted locations to exist on a network, but that doesn't really matter in this case. So a key thing to point out here in relation to what I've just sort of skipped over there is that the IP of this host is 7.131, and there's a network share on 7.128, which contains an XLA-M VBA add-in for Microsoft Excel. So what we want to do is add a registry key property which points to that location. And again, this is quite interesting because you can give it a UNC path. It doesn't have to exist on the system that you're using. So you can use a UNC path if you want to load things from a file share and get code execution that way, despite the fact that macros are enabled and trusted locations are, macros are disabled and trusted locations are disabled. PowerPoint also has VBA add-ins. The file extensions in this case are PPA and PPAM, and a Microsoft Word thing. It doesn't really matter if you rename them, you can call them whatever you want. You do, however, configure them a little bit differently. So the idea is the same, that you're supposed to sort of drop them in the startup location for Microsoft PowerPoint, but they don't get loaded automatically. You do have to create a registry key property which points to them. Now, that registry, you create a registry key, and then there's a couple of properties, and one of those points to the file. So in normal sort of use cases for the path property, you would just give the sort of the file name itself, and it would know automatically to go to the startup location for Microsoft PowerPoint. However, it turns out that you can also give UNC paths in the path location. So if you want to load it from a file share, you can do. The remaining add-ins that I'll talk about are based on COM, Component Object Model. Now, I wanted to give a very brief overview of this because if you're not familiar with COM, it might make some of the later examples a little bit difficult to understand. So it provides a good bit of background. As a security community, I guess we've only been hitting COM hard over the past year. So you might not be familiar with it, but it has been around since the early 1990s. And it's still extensively used in modern versions of Windows. Effectively what COM is a sort of a binary interface for creating reusable software components. You can think of the non-Wikipedia definition as, you're just defining effectively a bit of middleware. So you're creating software components which have a consistent interface, and then that interface can be used by many different programming languages. They only need to know how to speak the interface, not necessarily how the software component is implemented in the background. There can be many different file extensions for COM objects. Some of these, for example, are DLLs, OCX for ActiveX, and SCT, which people might be familiar with from Casey Smith's application whitelisting bypass research, which is XML files. So you can have many different formats for COM objects. And even if you haven't, even if you're not familiar with COM, you will definitely have used it if you've used a modern version of Windows, but you might have explicitly used it as well, even if you didn't realize it. And I think the best example of that is with wscript.shell. So if you've ever written a bit of VBA code like this to spawn an application, wscript.shell is COM. And just to sort of demonstrate what I've been talking about, you can use that same COM object in Microsoft PowerPoint. You can use the same COM object in JavaScript. Now, in order to sort of provide a bit of background on the COM add-ins for Microsoft Office, I wanted to provide a very sort of simple and primitive re-implementation of wscript.shell, just to kind of show how things work. So a couple of things to point out here is that The namespace, so this is a bit of C# code, and I've chosen this because it abstracts away a lot of the sort of underlying magic of COM and makes things very simple to understand. So we have a namespace called inconspicuous com_add_in, and then we have an interface and a class. So the interface, as interfaces do, just provide a sort of a definition of a method, and then the class derives from that interface and provides the implementation. Both the interface and the class have been made COM visible, and each has been given a GUID. So in terms of wscript.shell, you can think of the inconspicuous com_add_in as wscript and the class connect as shell. And then, if you remember from the previous example, you instantiate that, and then you call a method on that, which was called run, but in this case it's run command. So how do we go from this, if we generate this as a DLL, to wscript.shell? So that kind of makes sense in terms of naming, but how do we go from that to actually executing commands? So of course this is all done in the registry. Now, if you were to look online about how you register a COM object, you'll get told to use tools such as regasm. And if you run that tool against the DLL, so you run regasm, give it the path of the DLL file, it will create the registry settings for you. And that requires administrative rights. And the reason for that is because COM registration information lives in HKey class's root in the registry, which requires administrative privileges to write to. However, this area of the registry for COM registration is really just sort of a virtual area, because it's a combination of information taken from HKey local machine, which also requires administrative privileges to write to, but HKey current user, and that information will actually get synced when you log out. So if you actually go and manually register a COM object, and you just do it in HKey current user, that COM object will be available to you as a user without requiring administrative rights. So to show a sort of a very basic example of how you would register a COM object, this is a set of this is a .reg file for creating registry keys and associated properties. So in this example, I split it into two sections. There is a registry key created called inconspicuous com_add_in.connect. So think of that again, wscript.shell. And then there's a subkey called CLSID, and that's been given a GUID. And one thing I should have mentioned on the previous slide actually is that this GUID here is considered the class ID, CLSID, and this one here is considered the interface ID, IID. So you might have heard about this one before, the CLSID, and that is here. So we've got a name that's associated with a GUID, and then that GUID at the bottom also has a key associated with various other keys and properties. Now, a couple of big ones to point out are the code base property, which points to the file on disk that implements it. So at a very high level, we can see how we go from that name through to a GUID through to the file that implements it. So this is because I'm using a managed binary to do this, this GUID here kind of indicates that. So it's basically saying that this is sort of a .NET binary. And it turns out that although I'm using the same naming convention as the namespace and class, you can actually change this to something else if you want to. So if you use regasm on that DLL, it will actually use this naming convention, but here you can change it if you want. So it doesn't have to be inconspicuous com_add_in.connect, it can be not wscript.shell. Where it does matter, however, is here for the class. So when you point it to the code base, you also need to give the exact class name. If that's wrong, then it won't work. So once you register the COM object, if you run this .reg file, it will then be available for use. So to show an example of that, we have the .reg file on the desktop, and that's got the registry edits that I've just shown on the screen. Now, that points to a file on the desktop, which is the DLL file there. So if we run that reg file, make those registry edits, again, just showing that this can be done as a low privilege user. So if we run the reg file, now if we open up Excel, we can start writing VBA code, or indeed in any other language, using that com object. So same example as before, but instead of calling wscript.shell, it's calling the com add-in, the com object that we've just registered. If we execute that, that will give us code execution. Now, that's all very interesting, but how does that relate to Microsoft Office persistence techniques? So one of the ways in which you can use com within Microsoft Office is through what's known as Excel automation add-ins. And this is a specific use of com in that the methods that are available within a com object become available as formulae within Excel. So in terms of registering and actually making Excel do that, all you do is basically follow on from what we just did. We take that that com object, we register it with Windows, and then we need to do some application-specific stuff after that to tell Excel to use it. And that's quite simple. We just create a registry key property. And this is the same registry key property that we saw before. It's the open property, and again, you can have multiple of these with the integer on the end. Only this time, the value of that registry key property is not /r for read-only, it's /a, automation, and then the name of the com object that we've just registered. So, quick demo of this. Again, following on, so we've already done the registration with Windows, and now we want to register it with Excel. So we can just add that registry key /a, and then the inconspicuous com add-in.connect. So if we go and do that, we should then, the run command function should now be available as a formulae within Excel. And of course, in this case, it's very explicitly executing commands just to sort of draw the narrative between wscript.shell and a custom com add-in. But that could be something more inconspicuous, such as, counting the number of cells in a range and executing, but in the background you're injecting shellcode into another process or something. The problem with this form of add-in is that you actually do have to call the function in Excel. So for example, it goes back to sort of template files, for example. You can have a bit of VBA code that, for example, on the creation of a new Excel document, a blank document changes a cell to have another blank value, but also executes this function at the same time. It is a little bit more problematic. Of course, you actually have to have this additional stuff. But again, this is perhaps, if you're in defense and you see this, you're less likely to think that there's something suspicious than looking at a load of shellcode in VBA. There is, however, the option to do something far more interesting, because there is a specific type of add-in called a com add-in, which is, unsurprisingly, is also based on com. And this is particularly interesting because you can have a single add-in that works for multiple applications. You don't have to do any application-specific stuff to get your add-in to work with Word as you do to get it to work with Excel or even Microsoft Outlook. The way that you do this is you implement a specific interface. So if we remember in the previous example where we did the re-implementation of wscript.shell, we explicitly defined an interface. Well, Microsoft Office, when you install it, has a set of libraries which define this interface for you, and that's called IDT Extensibility 2, and that provides 5 methods that you have to provide implementations for. One of those is the onConnection method, and that will, unsurprisingly, execute code when that com add-in is connected to an application, for example, at startup. The way that you use these is very similar to what we've just seen. You register it with Windows in exactly the same way that we have done before, and then you have to do the application-specific registration at the end. And for this, you create a registry key here, and the name of this key is the name of the com object that we've just created, and then there's various properties associated with this, but the main one that you only really need to be concerned about is load behavior, which takes a value of 3, and that means load at startup. So here's a code example of a bare bones COM add-in. We can see that up at the top we have this class, which has the GUID and the COM visibility that's been sort of marked out in C#. And then this time it's deriving from that IDT Extensibility 2 interface. We're not implementing that anywhere because it's actually implemented in the Extensibility library. And here are the 5 methods that you have to provide an implementation for, which are only implemented here really in terms of this one, the onConnection method. So when an application loads this COM add-in, it will do the same thing as before. It will just spawn calc. So to show an example of this, we have once again a .reg file on the desktop, which will make the registry edits for us. The code at the top is exactly the same. We're using the same things time and time again to register the COM add-in with Windows, the COM object with Windows. And then the only difference is at the bottom we're doing this application-specific stuff where we're creating the registry keys, which have the COM object name, and we're doing that for each of the applications we want to use it with, and each has the registry key property of 3, which means load at startup. So if we make those registry edits, now if we go to launch any of those applications, we should get code execution at startup. So Excel, and the add-in is exactly the same as the one that I used on the previous slide. So it's a very bare bones bit of code, but it works every single time, and even for Outlook as well. So the last COM add-in that I'll talk about is the one with the most limited use case, but perhaps the most fun. So this is a COM add-in which applies not to Office applications per se, but to the VBA editor. So the goal here is not to get code execution when somebody opens Microsoft Word, but it will execute code when somebody tries to see if there's any VBA code contained within that document. The COM add-in, the COM object that you use for this in terms of the code, you can use the exact same code as was in the previous slide. So the VBA editor also implements the IDT Extensibility 2 interface, so you can use this. The way that you register it is also exactly the same. You do the Windows-specific stuff, and then you do the application-specific stuff. In this case, creating a registry key property at this location, which again takes the COM object name, and then there's a few properties, but again, load behavior makes an appearance. So just to briefly show this, if we open up Microsoft Word, we're not going to get anything executed. And if we Alt F11 to shortcut into the VBA editor, no macros, nothing gets executed either. So here's the code sample. Everything at the top is the same. The only difference is the application-specific stuff. And I should say as well that so this will work with all VBA enabled applications. So you don't have to enable this for the VBA editor in Word and Excel, etc. They all use the same settings in the registry. So if we open up Word now, nothing gets executed. But if we open up the VBA editor, we get code exec that way. To summarize the techniques that I've talked about, not in any detail, I don't want to go over these again, but I wanted to highlight some key themes of this. A big thing is where registry edits are required. So there's only 3 cases. That's for the WLL add-ins for Microsoft Word, and the XLL and the VBA add-ins for Microsoft Excel. Now, it's also these 3 cases where you may be able to use these add-ins for persisting within transient VDI environments. So if they're doing virtual desktop infrastructure environments, so if they're refreshing every 24 hours, if they're not using roaming profiles, you're not going to be able to just drop files in the roaming profile location, and you're not going to be able to do registry edits because all of that's going to be wiped. But If, for example, they're storing their trusted locations on a network share, as companies often do, and that is the case for the startup location, you may be able to potentially persist through that. Another thing is for the file extensions. So in every single case, apart from Microsoft Word, you can use arbitrary file extensions for any of the add-ins, and none of the add-ins require administrative privileges. There are some things that I didn't cover, which I just briefly wanted to highlight off for coverage sake. The first one is Visual Studio Tools for Office. So if you were to go online now and look for how do you create an add-in for Microsoft Office, this is pretty much you would get all your information for Visual Studio Tools for Office add-ins. And this has sort of been the same for about, I think for the past sort of 7 or 8 years, Microsoft has been pushing this as the add-in of choice. And it's supposed to be a replacement for the COM add-in. So the COM add-in is more legacy, I guess you could say, but again, still supported. Effectively, what VSTO add-ins do is simplify the IDT Extensibility 2 interface. Rather than having to implement 5 methods, you only have to implement 2. They are, however, a little bit more noisy when you register them, so I would recommend just using COM. Outlook rules, which I guess most people would be familiar with, but if not, in short, there is a specific, or there's actually a couple of rules which you can use to execute binaries or scripts within Microsoft Outlook. So when an email comes in and triggers a particular rule, you can execute a command, for example. Those rules that you define get synchronized to Microsoft Exchange, which is quite good for, again, sort of persisting VDI environments or where there's potential incident response procedures in place to wipe machines, because they'll just get resynchronized down to a machine. There is the VBA for Microsoft Outlook. So I've shown a couple of times in this talk that there is a VBA editor for Microsoft Outlook. This was a surprise to me when originally looking at it because it seems such a bizarre thing, but it is there. You can have code that executes through VBA at startup in Microsoft Outlook. The problem, however, with this is that you have to lower the macro settings within Microsoft Outlook in order to get this to work, which from a sort of an ethical security practitioner standpoint is arguably a dangerous thing to be doing, because you don't know what bizarre ways Microsoft Outlook is going to behave. This is a registry key which has been around for quite a long time. You just point it to a DLL and that will get loaded at runtime. And more recently, there's been the command line switches that has sort of been popularized for Microsoft Office. So for example, you can have a command line switch for when you launch Microsoft Word, which takes /t, and then you can have like an alternative template file that you want to use. You can even do /h and have it load from a web resource over HTTP. The problem, however, with these is that when you come to look at their practical application, it's sort of quite challenging to think how they might really be used, especially when there's much better options. And of course, all of the other stuff that I didn't cover, which requires administrative privileges. In terms of where Microsoft Office is going in the future for add-ins, it's all going to be about web add-ins. So these are extremely interesting because you can create add-ins that are not just cross-application, but cross-platform. So you can have an add-in that works not only on Microsoft Office for Windows, but it also works on Macs and it also works on Android. Now, the reason why it works this way is because your add-in is effectively an XML manifest file, which points to some JavaScript and HTML code, and then there's an API which allows you to modify parts of your document DOM effectively. I had a quick look at this, and there wasn't any obvious ways of executing operating system commands. However, it could be a very interesting research project if somebody is wanting to look at that. On the defensive side, if you're wanting to just prevent people from using these add-ins, that's possible for some of them, but not all of them. So if you disable, there is a specific section in the Trust Center for disabling add-ins, and that will prevent the ones that I mentioned here. So in Excel's case, only the place where you do the open registry key property with the /r value, PowerPoint's VBA add-ins, Excel, COM and VSTO add-ins. By enabling this, you will prevent anybody from using them, but of course that also prevents legitimate use cases. So you can require that add-ins are signed by a trusted publisher, which is just here. However, if you do that, I would highly recommend that you also tick the option below it, so you can click the top two, because if you don't, users will be presented with an interface such as this at the bottom, and it's actually possible to click through that warning. So if you're just enabling trusted publishers, you can click through that, which of course everyone's going to do because nobody wants to do work with a big yellow bar at the top of their screen. For the other add-ins, so the WLLs, XLLs, and the XL VBA add-ins, you can't really do that. This technique doesn't work for preventing people from using them. Interestingly, a good way of thinking about the distinction of where it works and where it doesn't work is where registry edits are required. So if you note from the previous table that these were also the 3 situations where you didn't need to make registry edits, it seems like if you do need to make the edits, then you can prevent people from using them, but if you don't, then they'll work regardless. So in terms of the options that you have, remove or relocate trusted locations. If you don't need to have startup trusted locations, remove them. If you do, perhaps try to remove them, relocate them to an area where a low privilege user doesn't have write access to. But also improving detective capability. So monitoring trusted locations for changes, and that can be changes to existing files, and also remember that file extensions in most cases doesn't matter, so you're not just looking for add-in related extensions. It really can be just about anything. I've mentioned various registry key properties through the talk, developing detective capability about changing here. So again, not just new keys that are added and new properties that are added, but also changes to existing ones, and then basic EDR stuff around looking at process relationships. In conclusion, so this talk has obviously been about persisting with Microsoft Office, and there's broadly been sort of 3 types of add-ins that I've talked about, those based on DLLs, those based on VBA, and those based on COM. Thank you for listening. If anyone has any questions, I'm very happy to answer them.